Okay, 42.3, the exercises. The wording I have not changed. He says find the limits of x. Nowadays, we'd say solve for x, and then we don't say express the answer in interval notation and possibly to graph the solution set. So I would claim looks like a very difficult problem. Now, certainly what I would do initially is just simply expand it, all right? So let's expand it. And what do you get over here? And we've been expanding things for some time now. I'm hoping it's relatively simple to expand. What are you going to get? 8x cubed. Again, it requires a little bit of thought here. Let's see, 4x squared times 3, minus 3, minus 12, and then times 3, minus 36, x squared, and then you're going to get plus, let's see, 3 times 2, 6 times 9 is 54, and then it's going to be, let's see, 3, that's going to be 20, minus 27, minus 71. I got to expand the other side now, and that's going to be what? Let's see, 2x squared times 4x, 8x cubed. Let's see, minus 4, minus 5, minus 9, minus 36x squared. And let's see, you get plus 10 times 4, 40x. I'm going to subtract 8x cubed from both sides. This has no effect on inequality. I'm going to add 36x squared to both sides. And this is actually good news because, I had a degree 3 polynomial. Now it's reducing itself to a degree 1. And let's do minus 40x from both sides. And I am going to add, let's see what that would be, 98. I'm going to add 98 to both sides. And what would you get? Well, let's take a look at that. You're going to get 14x. Let me go back to black ink. And this had no effect on the inequality. And what do you get inside 98? Now, you can multiply both sides of inequality by a positive number without changing its sign. You could also divide, when I say change the sign, change the direction of the inequality, I should say. Or you could divide both sides by the variable's numerical coefficient, as long as it's positive. That'll have no effect on inequality. So we're going to get x is greater than 98 over 14, and that goes in a nice number of times. So I'm going to say the limit of x has to be greater than 7. And this is what Wells is asking you to do. Nowadays, we would say solve for x. That would be the solution. The next thing I'd recommend you do is you graph on a number line where this is. So our conventions nowadays put a circle around the number that we're interested in, which is 7. And then what's x? X is greater than the 7. It can't touch it, though. So it's on this side, right? This was known as a graph. And the intervals move left to right. It starts at 7, goes off to infinity. Our conventions are parentheses when you're not touching something. 7's on the left, we're not touching it, a left parentheses. Infinity's on the right, that's a right parentheses because you could never touch an infinity. This is what's known as interval notation. Interval notation, all right? So let's take a look at the answer key, see if they've got that. Again, this is what Wells is aiming for. What am I aiming for? The intervals. Thank you.